How's it going, everyone? Welcome. Another video here looking at the front-end system design, specifically to the network connectivity. So because over the couple past video, what we have looked is how can we now describe the fundamentals when it comes to design front-end applications at scale, and then understand that when you're going to build applications, it is the anatomy of this is made of the back end, API, and front end. In our case, what we really care about is the front end and the responsibility that we have right now to work with our data and to build these UI applications at scale. So first, we need to take care of the API communication, which is something that we're gonna discuss in today's video. Server-side events, or this push notification, server events or push notification event, this pushing server technology, the API communications, as well as the data management, how we're gonna store and handle our data, and how we're gonna handle all of this complex user interaction, as well as the assets management. HTML, CSS, JavaScript, image, fonts, how we're gonna store that and organize that in a way that we actually get what we wanted to improve the user experience. So today we're going to talk about is on the server side. That's right, my friends, server side. I just want to actually server side, no, right? It's server events. My bad. This push notification. Okay, so developing a web application that use server sent events. All right, there you go. The goal: set up a persistent, set up a connection, set up a persistent connection, right here. Okay, cool. Today we're gonna talk about is the describing navigation, OS models, response, communication type base, and is this right? We'll first discuss about long polling. Okay, this is now this one, right? The long polling. Cycle application state design, network connectivity, and all of this, and TCP based long polling. TCP based connection, exactly, TCP based connection, we can say is this one. So long polling, right? And there you go, TCP base. As it is. So long polling, TCP base. Then we also have now is the server events, right? Server event, exactly. All right, next one is server event. That's right. So first we're going to hear about let's going to read about this, right? So developing a web application that use server events is straightforward. Server event. This feature is available in web workers. And as we discussed, that web worker is just a web technology, it's a web technology from It's a technology from the web. It's a web technology that create now a thread where now allows to share data across different JavaScript engines, across different JavaScript instance, or across different JavaScript threads running the JavaScript engine. So that's quite interesting. Traditionally, a web page has to send a request to the server to receive new data. So that is, the page requests data from the server. So with server event, it is possible for a server to send new data to a web page at any time. So by pushing message to the web page, this incoming message can be treated as an event plus data inside of a web page. Firefox does not currently support the use of server send events in service worker. It does not support them in a dedicated and shared workers. That's quite challenging here. However, the goal of this, okay, and I would like to, right, so what is the goal of this? I would like to put this here. So what is the goal of this? Right? So what is the goal of this? Set up a persistent connection. Pretty straightforward. On the client side, you want is to actually do this short or long polling. Okay? This is not talking about long polling. It's that every X amount of time, you're gonna use a timer from the web and send a request. The problem with this approach is that, as we discussed earlier, is that anytime you need to make a request, what happens is that because it passed through the OC model, this open standard interconnection, open system interconnection, and if we remember the layer on top, on each one of them, you have now the application, which is now where the user interact and the browser use some of the network service. Let me actually do this, right, as a way to recap that. So you got now that. Let me see if actually I can use this image. Yeah, from Cloudflare. Shout out to Cloudflare. God bless you. Oh man, totally, bro, totally. The Pachamama bless you, bro. Whoever, Ganesh, Shiva, whatever. Bless you, bless you. Okay. So we got this, right? So we talk about is this OC model, all right? So anytime we now wants to do this long polling as a way to establish persistent connection, well, the thing here is that we are going is to pass through this OC model, all of this layer where this bit of data is being added to the data that we want to send as a way to know what and how is going to this different computing system with different architectures, they're going to now exchange that. They're going now to interconnect with one another. How they're going to exchange that data. So that's why, thanks to this particular model that is now the successor of the X.25, which is this protocol switch base that won the protocol war, we barely hear about this because that happened on the 1960s, during the 60s and the 70s, right? We're quite familiar with the browser wars, and similar that now we are quite familiar with the attention wars made by these kind of companies, especially social media accounts, right? So when they say it's like, hey, attention here is the currency. Attention here is the currency. So because of that, right? And since we wanted to now send this message or send this request to a server, okay, both of them implement now this OC model, where it now first is passed through the application layer. This is now the human computer interactions, where the application actually now can have access to the network services. Then you have the presentation when you say, hey, let me ensure the proper data. Let me ensure that this data is in a usable format, and it is. Let me ensure that this data is in a usable format, and this is when encryption happens. So then you move on to the season, where now ports. This is now where ports are controlled. Okay, this phase is responsible for controlling ports, seasons, and maintain connections. And anytime we want to maintain a connection here, right? Because at the end of the day, anytime you send this HTTP, you just only is open a port, create these connections, pass through the transport layer, where you're going to define is the protocol that we're going to use as a way to send this particular data, whether it's TCP or UDP, connection based or not, or connectionless. In our case, we're going to use the connection based TCP, specifically the HTTP protocol, as a way to say, hey, this is not the protocol we're going to use as a way to send this hypertext document. All right. And then now it passed through the network layer as a way to identify what is the physical path that this package, this data needs to go with, right? And then the data link, which makes now the transfer between the devices much more cleaner by saying, hey, let me now put a format on how this data is going to be transmitted on the network. Okay, and then finally is transmit the raw bits of data over the physical medium. So because any time in this particular case, right? So because anytime we create not only this, anytime we actually call the fetch API, we want this to now open, or we want this to send a request. We open a TCP connections. So we open a new socket. So a new socket is created thanks to the OC model, okay, in the season phase, and this is something that happens any time you now call that function. Let's see if this actually is true, my friend. From the API, right? Fetch API. The fetch API provides an interface for fetching resource. It is a more powerful and flexible concept for that, because it says the fetch API uses request and response objects and other things involved with network requests, as well as related content such as scores and the HTTP origin header semantics. For making a request and fetching a resource, the use fetch method is the global method in both window and workers. Interesting. This makes it available in pretty much any context you might want to fetch resource. The fetch method takes on one mandatory argument, the path of the resource you want to fetch it, returning a promise that resolves the response. As soon as the server responds with header, even if the server responds with even if the server response is an HTTP error status, you can also optionally pass the init options at the second argument. So once the request is retrieved, there are a number of methods available for that. The question is that how the things is working behind the scenes, right? Because this is how you can use fetch API, but you want to know is what's happening behind the scenes, right? Making a request. To make a request, call fetch passing a definition, and optionally an object that contains is the configure of the request. This is setting the methods, all right? So you do is the get, right? HTTP request methods. That's right. So you say HTTP headers and request methods and all of this. Again, the question still remains. The question still remains, which is, let's gonna ask ChatGPT about this and give me sources from that. Similar to Perplexity, right? It's like provide a trustworthy link where it explains if it is true. It explains if it is true. A trustworthy link where it explains if it is true that any time we call the fetch method, it creates a new connection and open a new socket in our computer. It does not create a new connection every time it is called. Instead, the behavior depends on the underlying implementation of the browser or environment. Connection reuse. Most other browsers implement connection pooling, which allows them to reuse existing connections for multiple requests to the same origin. This means that if you call fetch multiple times on the same URL, it may reuse an existing connection instead of opening a new one each time. HTTP 1 and keep alive is the way of how you can persist the connection, also known as keep alive, are used by default. This allows multiple requests and response to be sent over a single connection, reducing latency and improve performance. HTTP 2 multiplexing allows multiplex requests to be sent over a single connection simultaneously. This further optimizes resource usage and reduces the overheat of established new connections. Force new connections. If you want to ensure that new connection is created for fetch request, you can use certain options in your request. For example, in socket.io, you can specify options that force new connection when creating a socket. So, okay. And this is the exception. An example. Good. And specifications. Let control be null at the following abort step. Set locally aborted, abort. Course protocol and HTTP catch. Okay. Mhm. It's an ordered set of zero or more connections. Each connection is identified by an associated key, a network partition, origin, and a credential. A connection timing info is a structure. It's a struct used to maintain timing information pertaining to the process of obtaining connection. Domain lookup end start time, end time, connection start, connection end time. A connection pool. Concept connection pool reference here. A user agent has an associated connection pool. Okay. A connection pool. Yeah, a user agent has an associated connection pool. A connection pool is an ordered set exactly, that must not contain the item twice. A connection pool is an ordered set of zero or more connections. So each connection is identified by an associated key, a network partition. But it's interesting that the connection, a user agent has a connection pool. Connection pool, right? Is a cache of database connection. And he say apparently, because when and you say apparently and I really love about that, and I really love that. So you let's say talk about apparently. And you say that apparently Okay. So this is okay. So in theory, right? So because now the okay, all right. So because now, set up a persistent connection costs a lot of CPU time. And here is the article. Is the article. Okay. So apparently, anytime you are creating now is a connection. Anytime you are now request a particular file, it turns the CPU, right? Anytime you actually now make this connection. So since you open a TCP port, even though that user agents or browsers, as they like to technically call it like that, even though that they have now a connection pool, okay? Even though that, exactly. So even though that browsers, even though the user agents, browsers now contains a connection pool, all right, which is a cache. A connection pool is an ordered set, which is a cache of database connection. So you now maintain that. A connection pool. A connection pool. Right. A connection pool. Right. A cache. Right. A cache of database connections, or a cache of connections, right? Usually used in the context of database. So connection pools are used to enhance the performance of executing commands on a database. Opening and maintaining a database connection for each user, especially requests made to a dynamic database-driven website, it is costly and wastes resources. In connection pooling, after a connection is created, it is placed in the pool and it is used again, so the new connection does not have to be established. This is a theory. Because in practice, okay, or at least in browsers, when you are doing this long pooling, even though that the user browser has a connection pool, a cache of connections, right, which is this, so a cache of connections, it still consume more power. Exactly. So cost a lot of CPU times. And this is the article. Even though that the user agent now has a connection pool of cache connections, it still consume more power by creating new TCP sockets, by creating a new TCP port, right? By creating a new TCP port. So why this is important, especially here, because not only this user agent or this application, which is something that this particular concept you're gonna use, especially when you have now a when you talk to database, okay. If you have a server, when you need to actually talk to a database, you need to have a connection pool, a cache of connections. So you can now, instead of actually open connections or establish this handshake, all right, you already have that connection alive. So HTTP1 allows you to do this with keep alive, but even though, according to that particular article, it's still memory consuming doing this long polling, and even though that HTTP improved now the size of the compression of the header, which is data that you need to send once you establish the handshake, as a way to say, hey, this is the proper data, this is now the metadata about this data that we're going to send. Yes. So, all right. The other is energy consumption. This is one of the problems here. Okay, energy consumption. And the other problem is latency. Because, especially in mobile devices, when you are now moving through one antenna to another, so anytime you do that, because this connections is stateless, HTTP is a stateless connections, you need to, on the back end, find a way to actually keep that alive, right? So you need now a reconnection solutions in your backend. The answer. And not only that, but anytime you move on from antenna to another one, you actually do is a handshake, a TCP three-way handshake. So ACK, SYN, SYN-ACK, and ACK. So the TLDR of this is that if you plan to now provide if you plan to set up a permanent or if you plan to build an application where you need to set up a permanent connections, as long as it is on desktop application, this is great. If it is on mobile, you know what will happen, right? It is energy demanding. It gonna provide you latency. This is it, right? So when to avoid this long pooling is when you want to build is mobile applications. Okay, so far so good. Right now we're going to talk now at the server events. Finally, and it all started to actually fill the gap in our knowledge. All right, so when we talk about a server here, since traditionally we can make a request, so the client talk to the server. Now the server can talk to the client. So this is now a push technology. It's a pushing technology. And then here we're starting to see this. Okay, fetch standard. As well as the connection pool. Okay, interesting that it now has the browser itself have this particular dash record, this cache of connections. Okay, so this is a one-way connection. In this case, it's like you will need a bit of code on the server to string event to the front end, but the client-side code works almost identically to WebSocket. So in part of handling incoming requests, there is one-way connection, so you can send event from a client to server. So this is a push technology. It's a push server technology. It's a push server. It's a push server technology. Is a one-way push server technology similar to WebSocket, but now the server needs to be set up in a way to emit those events and prepare the client to listen for them using is the event source. to open a connection to the server. Okay. Using the event source. Interesting. The event source interface. Open a persistent connection to an HTTP server, right? Which send events in text event string format. However, there's some limits to this. However, HTTP 1.1 only accept up to 6 connection, 6 open connections, right? So HTTP 2 now can handle at minimum 100. Okay, makes sense. Which means you can have 100 taps per connection, right? Number of open connection, which can be especially painful when opening various tabs as the limit, in per browser, instead of a very low number to one fixed. Okay. Okay. Good.
The first alternative,
but it's using the event source on the
that
client.
we could potentially use to load pooling is the service end events. This is the server push technology. So it's a slightly different. So it's based on HTTP2, and the way it works is when you establish the connection with the server, the duplex communication is used only when you do the initial connection, just the initial three-way handshake. But the rest of the connection is basically the server pushes the data to the client. So in case of the service end events, the duplex antenna is not used. We only use the receive-only mode, and we do not drain the energy. Although we still have an issue with the reconnection where we need to do the three-way handshake, but the huge difference with the service end events that the reconnection is implemented on protocol level, so you don't need to handle that or do the three-way handshake. But the huge difference with the service end events that the reconnection is implemented on protocol level, so you don't need to handle that on infrastructure-wise. So you can always resume from the place where you started. And the huge benefit business-wise for using service end on infrastructure-wise, so you can always resume from the place where you started. And the huge benefit business-wise for using service end events, it's very easy to scale. So for instance, if if we have multiple instances of the server and one instance is died, we can just forward the request to a separate instance, and because we can always resume from the previous place using the service end events, so it doesn't matter for us which instance will respond. So since the service end events is HTTP2 based, it also utilizes the TCP socket differently. We're going to talk about HTTP2 protocol just in a few moments, but the huge benefit of HTTP2 is because it has the multiplexing feature. The multiplexing allows us to open 200 requests within one single TCP socket. So this means while HTTP1 to fetch 500 HTTP2 is because it has the multiplexing feature. The multiplexing allows us to open 200 requests within one single TCP socket.
More.
So this means while HTTP1 to fetch 5 resources, we had to open 5 TCP connection, which is much less efficient. So the service end events is generally much faster than long pooling because it also doesn't send any junk data. So we don't send any unnecessary headers, and we receive only the data that relates to the content. And the summary for that is there are definitely pros for service end events because the connection is handled automatically. It's very battery efficient from the mobile device perspective, and it doesn't send any the overhead data. And the horizontal scaling of your infrastructure is much easier when you use the server send events. The cons, though, you can.
And the horizontal is like you can now have multiple applications per instance, which means that you can now use this horizontal scaling. In other words, harness the power of all of the threads and logical threads in your computer, unlike vertical scaling, where you say, hey, now I need to upgrade the hardware here.
Can't push the data to the server, and only the string data is supported by returning this. So you will need to parse the text payload that you send from the server. And when you need to use it, it's good for both desktop and mobile web applications. And it also provides a very good performance. So the performance comparable to the WebSockets that we're going to discuss on the next slide. And it's very good for streaming the large text data if you have this case. And the reason why you would avoid this is if you're building very simple desktop app. So then you'll be fine with long polling. You don't need to really overcomplicate the architecture of your.
So if we take a look now at the server events, right? Simple server sent event using PHP. Now about running this example through NGX. By default is on. Thus you have to add fast buffering off to appropriate location block for this instance. So you are serving this. So on the client side, now you are listening to this, and you're with credential ready state URL, okay, and then you say, now that I define here, so now that I set up this these connections to this server, okay, on this domain, for this particular resource is interesting, event source on the text event stream format. Okay. Then we're gonna take a look at the data, and we're going to inspect that. Hey, on open, yes, connection has been locked. Connection to the server open. And then on message, which is something that on the PHP you define here, where to me is quite fucked up. And the way you do that is by flush here, which is you're going to send that flush does perplexity, so does flush from PHP is of does flush method from PHP is the equivalent of response right or respond n in Node. Yes. Serve different purpose, although they are related to how data is sent to the client. Okay. In PHP, the flush function is used to send the output buffer to the client. Okay, the output buffer to the client immediately. This means that any content has been echoed or printed before the call to flush will be sent to the browser without waiting for the script to finish executing. It outputs buffering. If output buffering is enabled, which is often is, flush will clear the buffer and send it contents, allowing the real-time updates in the response stream. Oh man. So flush is now the way of how you can send the output buffer, whatever you have now on that store, buffer, something that you barely hear about that. Buffer is the way how you store it, to say buffering. Buffer, something or someone that help protects from harm. Okay, buffer. A shell, a shield. Interesting. Buffering from this back pressure, the metal part at the front back of the train at the end of the track. Buffer. Okay. As a way to buffer, as a way to protegerte de un daño. Buffering. Interesting. So now it output the buffering, but in the context of software, okay, it's a storage device used to compensate for a different in range of data flow. So I'm going to put all of this in the buffer as a way to compensate the difference of data flow when transmitting data from one device to another. So this is now what it's doing is flush in PHP is say, hey, I'm going to now send whatever I got in the buffer, whatever I got in this store as a way to deal with why do I gonna store this? As a way to compensate the difference in rate of flow, as a way to compensate what I'm getting here. Similar if you have now a glass of water, glass of water, or this one. All right. So this buffer is allows you to now store this data as a way to compensate is the different rates at which is being processing. So buffering in the context of computer science is this storage that allows you to now this storage for different data flows rates, right? Pretty much like you have a glass of water, right? So this storage actually now allows you to store is, for example, if you're pouring wine, right? It's allow you to now have this place where you can store your wine, which is served at different rates, right? It can be do faster, or much faster, or slower, you know. So this is buffering in the context of software, and in the context of life is a shield for protecting you. Whereas response end is used to signal that you have finished sending data for a particular response. Unlike PHP flush, which can be called multiple times through a script, response end typically called once. Okay, after all desired data has been written using response right. Send output immediately to the buffer can be called multiple times. This can be quite this. Again, when it comes to concurrency and that kind of thing, this thing is starting to become quite complex here. Allow you to immediately output during script execution. So what it's doing is that, hey, this is now immediately send the data that you have now in the buffer, and in the buffer is where you have print data. And then it's going to repeat that. We're going to wait for 1 second, and they're going to repeat that again. This, and then repeat that again after 1 second. And after 1 second, what it's doing is now effectively sending this piece of content, in this case, the time and the current time. And this is the message. Holy crap. Okay. All right. So here in the client, it say, hey, when the server is emitting something, and by emitting something is whether it's flushed or sending something. Hmm. You are now going to listen to that and then do something with that as a way to now append that element as it is. When this example was last year. Oh, that's very interesting. 6 years ago. And last commit was 1 year, merge brand into land. This was 7 years ago. Interesting. Very, very, very interesting. So this is events. Okay, so oh my god, this is now server events. So it requires you a little bit of configuration over the client, over the server, and use now the event source methods to listen to that particular file in there, right? One of the trade-off of this
Person events is etched.
So the benefit of this is that the communication starts as a duplex, okay, and then it only is, so the communication starts as a duplex and then it becomes one way, right? So it doesn't send junk data unnecessary. So for example, like headers, which makes them much more relevant, much more efficient. The reconnections are handled. Let me see if this is server event, server send event. Yes, is server send event. Yeah, is server send event handle reconnection automatically? Automatically? This is interesting. So reconnections is handled automatically. So reconnections are handled, because it's plural, I'll handle automatically. Yep. Reconnections are handled automatically. So reconnections are handled. So this is not the so the problems here. So the problems is that strings data is supported. String data, exactly. Only string data is supported. Only string data supported. And the other is problem 2. Client can push. You can push data to server. Only server side communication. All right. So that makes sense, and that'll be all for. Yeah.
Summary for that is there are.
So that'll be all for this video. Take care. Bye bye.